Hopefully you recall that when you take the inverse of a function, so if we're looking for y equals the inverse sine of x, that what this means is that we take our x's and our y's and we switch them. So this column comes over here to be our y's, and this column comes over here to be our x's. So we get 0, 0, 1/2 pi over 6, 1 over square root of 2 pi over 4, square root of 3 over 2 pi over 3, 1 pi over 2, 1 over square root of 2, 3 pi over 4, 0 pi, 5 pi over 4, negative 1 over square root of 2, negative 1, 3 pi over 2, negative 1 over square root of 2, 7 pi over 4, and 0, 2 pi. Also, remember with inverse functions that we take our graph and we flip it over the line y equals x. Remember, a function is where each x can only be paired with one y. So when we look at our values, we have this 0 goes to 0, but 0 goes to pi, and 0 goes to 2 pi. So what this means is that we have to restrict our domain so that we do not have these repeating values. And the domain we're going to restrict ourselves to is negative pi over 2 to pi over 2. So when we restrict ourselves to in here, in this box, then we'll get a function that will pass the vertical line test. So we're going to have our domain is going to be restricted to negative pi over 2, negative pi over 2 is included, to pi over 2, where pi over 2 is included. Remember, we can also write this in interval notation. So remember that 3 pi over 2 is the same as negative pi over 2. 7 pi over 4 is the same as negative pi over 4. And then we go back up to 0. So we have this, we're going to use this value, then we go back up to 0, 1/2, 1 over square root of 2 here, 3 over square root of 3 over 2, and then pi over 2. So these values with the dots are the ones that are between negative pi over 2 and pi over 2. So they're the points we're going to plot. So we have negative 1, 3 pi over 2. We have negative 1 over square root of 2. So we have negative 1, negative pi over 2. Negative 1 over square root of 2, negative pi over 4. We have 0, 0. 1/2 pi over 6. Square root of 3 over 2 pi over 3. And 1 pi over 2. So connecting our points, we get a graph that looks like this, which should look like what happens when we take this part of our function and flip it over the line y equals x. So we've said that the inverse function, denoted as sine to the negative 1 of x, or arc sine of x, is defined by y equals sine of x when x equals sine of y. In other words, this y is the angle at which the sine function equals x. And since we had to restrict ourselves to in this domain, we restrict ourselves to negative pi over 2 to pi over 2. So this domain becomes this range, becomes the range for this inverse sine function. So since this was the domain of our original function, it's now the range of the inverse function. And similarly, the range of the function sine of x is negative 1 to 1, so that becomes the domain of the inverse function. So let's try evaluating. Let's evaluate the inverse sine of square root of 3 over 2. So what we need to do is go to our unit circle. So we need to go to our unit circle. Let's make our unit circle a little bigger. And we need to find where sine is square root of 3 over 2 between negative pi over 2 and pi over 2. So that's this half of the unit circle, and we find square root of 3 over 2 at pi over 3. Alright, next let's find the inverse sine of 4/3. Well, we have a problem here because 4/3 is not in our domain negative 1 to 1. So this value is not defined. Now let's try inverse sine of negative square root of 3 over 2. So we look on our half of our unit circle for negative square root of 3 over 2 in the sine location, and we get that this is 5 pi over 3. So go ahead and pause the video, try these, and come back when you're ready to check your answers. So the inverse sine of 1/2, well, the sine equals a half at pi over 6. Inverse sine of negative 1 over square root of 2, we find negative 1 over square root of 2 at 7 pi over 4. Sine of 3/2, well, 3/2 is bigger than 1. This is undefined. Let's try evaluating some expressions with the inverse sine function. So first we have the inverse sine of the sine of pi over 6. So our strategy here is to evaluate this inside first. So we need to know sine of pi over 6, and that is 1/2. So this tells me that I have the inverse sine of 1/2. And where does the inverse sine equal a half? Well, it's at pi over 6. Next, we have evaluate the sine of the inverse sine of a half. So first, we do the inside. So the inverse sine of 1/2. And that gives us pi over 6. And then we find the sine of pi over 6, which gives us 1/2. So notice that we kept getting back. So here we said pi over 6, we got back pi over 6. Here we had a half, we got back a half. So for x between negative 1 to 1, if you have the sine of the inverse sine of x, then that's going to give you back your x. And similarly, if x is between negative pi over 2 to pi over 2, if you take the inverse sine of the sine of x, you'll get back x.